What's up, guys? Welcome back to the channel. Today in this video we'll be doing question 5 of this question paper. As you can see, this is a national certificate for mathematics and 4, and this question paper was actually written on the 27th of March 2026. It was an X paper that took 3 hours to be written. So before we start with this question, I'd like to let you know, guys, that I've already done question 1, 2, 3, and 4. I'm going to leave the videos of those questions in a playlist on the description, and also that very same playlist will pop up at the top right of the video that you're watching at the current moment. So before we finish with this introduction, I'd just like to say thank you very much, guys, for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel, because we've done question papers and topics on mathematics N4 and also N3 and N5. Let me say this: if you don't want to watch this video in a sequence order, I left some timestamp. You can click on the question that you like to watch. All right, people, we are done with this introduction. All right, guys, here is our question 5. Question 5 consists of 5.1, 5.2, 5.3, and 5.4, with 5.3 having two sub questions there. So we're going to start with question 5.1, solve it, and then we're going to do others later on. Let me create space so that we can able to solve this 5.1. Alright, guys, here is our question 5.1. They want us here to evaluate the following integral. Now, as you can see here, we have the limits there. Once you see the limits on the sigma, just know this is a definite integral. We need to simplify this expression before we integrate. So let's do it. As you can see, the upper limit there is pi over 2. So when you have pi over 2, it just know that that is in radians. You can change that into degrees by multiplying pi over 2 with 180 over pi. And then if you multiply this is going to give us 90 degrees. Just in case you didn't know, rather use degrees than radians. So if I rewrite this is going to be sigma. The upper limit is 90 degrees. The lower limit is 0. And then if you look at the numerator there, we have sine 2x. Sine 2x is a double angle identity that we can write as 2 sine x multiplied by cos x. There we go. And then we divide by cos x there. Close bracket, then dx. Then from there, we know that cos and cos, they divide each other. You'll be left with sigma, upper limit 90, lower limit 0. And then you are left with 2 sine x multiplied by dx. Now, when it's like this, we can start integrating. Now, when you integrate the definite integrals, there's no need for you to add c there. So let's integrate this one. We have y is equaling to, open bracket, we have the coefficient, which is 2 there, and then we integrate sine. So the integral of sine is actually negative cos x, then close bracket. Now, let's not forget that we have the upper limit, which is 90, and the lower limit, which is 0. Let me continue on top here. So as you continue, this is going to be as follows. The first bracket is going to be for the upper limit. If we multiply these two with negative cos x, this is going to be negative 2 cos x. There we go. Then we close the bracket. This is for the upper limit. Then we subtract them. Now, the second bracket is for the lower limit. It's going to be the same integral there, which is negative 2 cos x. Then that is for the lower limit. Then from there, what we do here, we start substituting. Now from here, we substitute the limit wherever there is x. So on the first bracket, we're going to substitute 90 wherever there is x. So we have 2 cos 90 degrees, close bracket, minus. And then on the second bracket, we have negative 2 cos 0. Remember, on the second bracket is for the lower limit, which is 0. So when you continue here, for the first bracket, we have negative 2 cos 90. That is going to give us 0. And then minus. And then inside there, we have negative 2 cos 0. That is going to give us negative 2. So the final answer, our limit is going to be positive 2. You can write unit squared there. There we go. This is our final answer for this question. Guys, this is what we call definite integrals. Just in case you did not understand how I did this one, I'll leave a playlist that contains the problems that we solve on definite integrals. Go to the link on the description, click on it, and also the very same link will pop up at the top right of this video. But if you manage to understand this, you can always leave a like, comment, subscribe, and also share the video if you know someone who's doing N4. Alright people, we are done with 5.1. Let's go and do 5.2. Alright guys, here is our 5.2. Now 5.2, they want us to simplify this integral here. So this integral, as you can see, it has three terms there. So before we integrate here, we need to simplify first, then we integrate later. Now let's start. We have sigma there, and then we have 3 sine x over cos. We know that 3 is a coefficient. Sine x over cos x, that is going to give us tan x. There we go. Plus, now the second term, we don't do anything. It's fine like that. And then the third term, we have 7 there. We also don't do anything. Now, when it's like this, we can able to integrate. Now, we integrate. We know that 3 is a coefficient. But then, what is the integral of tan x? When I look at the formula sheet, the integral of tan x is actually ln sec x. There we go. And then we move to the second term with pi over x. This is the integral of natural log. So the answer here is going to be plus pi ln x. There we go. And then we go to the last one, which is 7. 7 is our constant. Remember, when you integrate the constant, you multiply by the variable that you're integrating with respect to. In this case, that is x. So this is going to be plus 7x plus c. So here, this is our final answer, guys. Really, you're not supposed to worry about this one because it was straightforward. So guys, this is how you do it. Just in case you didn't understand, you can always watch at the point where you got confused, and if that doesn't help, you can leave a comment on the comment section. I've done videos on integrating polynomials. I'm also going to leave a playlist that contains those integral of polynomials. All right people, we are done with 5.2. Let's look at 5.3. All right, guys, here's our 5.3.1. Now they want us to sketch the graph of y is equaling to 4x squared and y is equaling to 2x. Calculate the point of intersection, show the area to be calculated and the strip to be used. So we have two graphs here. One is y is equaling to 4x squared. Let's call this one y1, and y2 is equaling to 2x. There we go. So we have these two graphs here. We need to draw them. Now let's start with y1. For the fact that we have x squared there, this is actually parabola. It's just that we do not have b and c. We only have a, which is the coefficient of x squared. So this graph here, what matters the most is the sign of the coefficient of x squared, which is a. And then let's look at graph 2 or y2. This is a straight line graph because we have x and then c is actually 0. We don't really have to find the coordinates here because since c is 0 for both of them, it means these graphs here, they will cut at 0, 0 point. Right, so let me draw the Cartesian plane and let's draw this graph. So this is all we need for these two graphs. Let's start with graph 1. I'm gonna draw it using a red color. Like I said, this graph 1 or y1 is actually a parabola. For the fact that our 4 is positive, we know that when a is positive, our graph will face upwards. Now that we don't have c and b, meaning our graph is gonna turn and cut at the origin there. So let me draw the graph and show you how exactly it's supposed to look like. There we go. So this is actually our graph. Guys, when you have a graph like this, especially a parabola, you don't really have to worry too much about it. Just know that you can draw it this way. You can also use the table if this doesn't make sense. Right, so let's look at y2, which is a straight line graph. Again, the straight line graph, we do not have c. It means our graph is gonna cut there at 0, 0. For the fact that our graph is equaling to 2x, it means that our graph is gonna pass at 0. So here's how our graph gonna look like. There we go. So here is our straight line graph. So these two graphs here, they interact them. So remember, they say we must show the area that we need to calculate. So the area they want us to show is the area that is created by these two graphs. So let me highlight that area. So this is our area. Let me first name these very quickly. This is y1, which is equaling to 4x squared. And this here is y2, which is 2x. Now, remember, they say we must show the representative strip. So the representative strip is supposed to be inside this area there. So let me just put it here. You can put it anywhere as long as it's inside the area. Change in x. There we go. So this is exactly how they want us to draw or sketch our graph there. But let's not forget, they also want us to calculate the point of intersection. Now the point of intersection that they're talking about are these points here, that one and the origin. So as for the origin, it's 0 0. Even if you don't calculate here, this is 0 0. The one that we need to find is the one here on top. So as you can see, both of these graphs, they're equaling to y. So in order for us to find those point of intersection, we need to equate these two graphs. So if we equate them, we can say 4x squared is equaling to 2x. There we go. And then we solve for x. We're going to transpose this 2x to the other side. So we'll be having 4x squared minus 2x. All this is equaling to 0. Then from here, we can take out the common factor, which is 2x. And then we left with actually 2x minus 1. This is equaling to 0. Now, when it's like this, we know that 2x is equaling to 0. And this one, if we transpose this -1 to the other side, we have 2x, which is equaling to 1. And then x here is going to be equaling to 0 if we divide by 2. And here x is going to be 1 over 2. There we go. Now we need to find the y values. So in order for us to find the y values, we can substitute these x values in one of these two equations. So rather substitute them in y2. So y is equaling to 2 when x is 0. So y is going to be equaling to 0. So we can say point A, we have 0 and 0, which is this one here. Already I've written it. Now let's look at the other one. We can substitute half there. 2 multiplied by half, and then this here is going to be equaling to 1. So we can say point B, when x is half, our y is 1. So this is the point here, half and 1. There we go. So these are the intercept that they were talking about. I hope you managed to understand these ones. Really, it was not that difficult. This is actually grade 12 work. But just in case you did not understand, you can go to the point where you got confused, rewatch at that point, and if that doesn't help, you can leave a comment on the comment section and I'll try to help you to my level best. But if this part of the video helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. We are done with 5.3.1. Let's go and do 5.3.2. Alright guys, let's look at 5.3.2. The question goes like this. With the aid of integration, determine the area bounded by the two graphs. So they want us to calculate the area that we highlighted in yellow there, which is created by these two graphs. So in order for you to calculate this area, you need to know the upper limit and the lower limit. So the formula is like this. A is equaling to sigma. The upper limit, let's say, is x2. The lower limit, let's say, it's x1. Then inside here, we have y2 minus y1. I'll explain this later on, multiplied by dx. Now, let's start. Remember, we have area, which is equaling to sigma. Now, x2 is the upper limit. How are you going to find the upper limit here? Guys, the upper limit is the x coordinate of these two intersections, which is bigger. So in this case now, half is the one that is bigger than 0 here. So we're going to write half there. And then the lower limit, it's actually this one here, which is 0. So this is going to be 0. You only take the x coordinate of the intersections, guys, not the y coordinate, because you are actually integrating with respect to x. So that's why the x values. Remember, the upper is the one that is bigger, the lower is the one that is smaller. Right. Now let's explain why are we saying y2 minus y1. Right. If we look at the area that we highlighted them, it's going to help us which one is going to be negative and which one is positive. As you can see, we said y2 is positive. Y2 is positive because the green graph, which is Y2, when you look at the area that we highlighted in yellow, the green graph is at the top of that area. So that's why that is positive. So remember, Y2 is actually 2x. There we go. And then the red graph, which is Y1, the parabola, it's underneath the area that we highlighted them. So this is going to be minus 4x squared, which is Y2. So we multiply by dx, by the way. Then from there, we just apply our definite integrals. So let's do it. We know that a is going to be equaling to, then we integrate this. These are standard integral, guys, so you don't have to worry about them. So we know that this is going to be 2x 1 plus 1 divided by 1 plus 1. There we go, minus. And this is going to be 4x 2 plus 1 divided by 2 plus 1. Then we close them. We write the upper limit, which is half, and the lower limit, which is 0. Guys, when you do definite integral, there's no need for you to add plus c there. Right, so let's continue. If you continue, area is going to be equaling to, we're going to have the first bracket, which is going to be 2x squared divided by 2, minus, we have 4x cubed divided by 3. Then we close there. So the first bracket is for the upper limit, which is half, minus. Then the very same integral that we got here on the first bracket, we're going to write it again. So it's going to be 2x squared divided by 2 minus 4x cubed divided by 3. And then we close the bracket. Let me create a space here so that we can finish our problem there. Let us not forget our lower limit, which is 0. Right, so we continue. As we continue here, you can see that 2 and 2, they're going to divide each other. You're only left with x squared. But instead of writing x squared, we're going to write 1 over 2 squared, because we start substituting x with our limit there. In this case, it's half, the upper limit. And then we say minus, and then we have 4. And instead of writing x cubed, you're going to write 1 over 2 cubed divided by 3. And then we close the bracket there, and then minus. And then on the second bracket, we're going to substitute with our lower limit, which is 0 wherever there is x. So it's going to be 2 0 squared divided by 2 minus 4 0 cubed divided by 3. And then we are done there. Then we move on. On the first bracket then, we got 1 over 12 minus, and then the second bracket, it's 0. So the final answer is actually 1 over 12, or 0,083 unit square. Guys, this is our final answer when we calculate our area. I hope you guys managed to understand how to calculate the area. If this helped you to understand, do not forget to like, share, comment, and subscribe to the channel if you haven't subscribed. But if you got confused somewhere, you can always watch the point where you got confused. And again, I have left some playlist on the description on how to do definite integrals, which is what we applied on this question. All right, people, we are done with this question here. All right, guys, here is our 5.4. They want us to integrate the following here. So we have to simplify the terms that need to be simplified here. As I look at this, I know that the last term need to be simplified because we cannot integrate with the root on our term there. So let's do it. So we have sigma, and then the first term is still fine. We have 3 cos, and then we have half multiplied by x minus a to the power of negative x, plus we need to change that cubic root x into x to the power of 1 over 3 dx, like that. But we are not done because we cannot again integrate with x on the denominator, so we need to take this x to the numerator. So we're going to rewrite the first two terms again. We have 3 cos half x minus a to the power of negative x. If we take this x to the numerator, our 1 over 3 as an exponent is going to be negative 1 over 3, close bracket, dx. So when it's like this, we can start integrating. Now let's integrate. So y is going to be equaling to the first term with 3 cos half x. So we have the coefficient, which is 3. The integral of cos half x, we know that is going to be positive sine half x. But then we know that our x has a coefficient of half. We need to divide by half them. There we go. Minus. The second term is exponential integral. So when you integrate exponent, you first write a to the power of negative x divided by, now the coefficient of x, you must multiply by it on the denominator with ln base a, right? And then we move to the third term. The third term, remember when we integrate this, it's very simple. It's going to be x to the power of negative 1 over 3. Because this is a standard, we add plus 1. And then we divide by negative 1 over 3 plus 1 plus c there. There we go. Then from there, we start simplifying. Let me create space so that we can simplify this one further. So let's continue. If we continue here, the first term, we can multiply these two with that 3 there. This is going to give us 6 sine half x. There we go. Divide by this one. Even if you don't write 1, it's still fine. And then we see we have negative and negative there on the next term. So that is going to give us positive. And then we have a to the power of negative x divided by ln a. There we go. So we can say plus, let's start with x there. We have x to the power of negative 1 over 3 plus 1. That is going to give us positive 2 over 3 as an exponent. Divide by the same 2 over 3. There we go. Plus c. So we are not completely done because we still have a fraction on the denominator. So if you write the final answer, this is going to be y is equaling to 6 sine half x plus a to the power of negative x divided by ln a plus, now we have to multiply by 3 on the numerator there. So this 3 is going to be there. And then we have x to the power of 2 over 3 divided by 2 plus c. So this here is our final answer, guys. I hope you managed to understand how to integrate this polynomial. Like I said earlier, if you don't know how to do polynomials, I left the playlist on the description. Go and click on the polynomial integrals and you will see different type of polynomials that we integrated. Just in case you manage to understand this, do not forget to like, share, comment, and subscribe to the channel. We are done with question 5 and we are also done with the whole question paper. So guys, I hope this video helped you to understand how to solve these type of questions. Until next time, guys, thank you very much for watching. Cheers.